Today I am going to teach you about 8.3 comparing populations. This is the last new lesson of material that you need to know for your quiz coming up on Monday. If you would, go ahead and take out your red pen and I want you to fill in this important information. All right, the first word that we see here today is called an outlier. It's a number that is much smaller or greater than most of the data set. So here in the data set, you can see a 55, 58, 62, and 189. Class, which one would you say is the outlier there? 189. How come?
Because it's so much bigger.
It's way bigger than the other numbers in the data set. So I want you guys to circle that with your red pen, showing us 189 is definitely the outlier there. Let's look at the next one. The median. Everyone say median. The most accurate measure of center whenever there are outliers. I want you to underline with your red pen the words measure of center. Anytime you see measure of center, that is another word for the median. You're measuring the center or the median, which is the middle. Next up, have we ever heard of this word quartile? Yes. Yesterday we talked about some different parts of our box and whisker plot. The lower extreme. Guys, what was the lower extreme? Yeah, it was the lowest number. Okay, what is the upper extreme? The highest number. Good job. The median is the one in the middle. And then we had two other ones, the upper and lower quartile. Very good. Okay, so that's where we get this phrase right here, the inner quartile range, or the IQR. I want you just to underline that word, IQR. We're going to talk a lot about that today. Another thing that you can be thinking the IQR is the range. This is the difference between the upper quartile and the lower quartile in a box and whisker plot. Next up, skewed. When one whisker appears way longer than the other. So yesterday, all of our box and whisker plots had the same length of whiskers coming off the box, but skewed would be if one whisker was a lot longer and another one was shorter. Finally, you're going to use the median in the interquartile range, remember the IQR, when either one or both distributions are skewed instead of the mean. So let's use all of that information. First off, I want you just to be able to identify if something is skewed or not skewed. Go back to your notes that you just wrote and read to me what it says in red about what it means to be skewed. Go ahead.
When one whisker appears longer than the other.
Okay, when one whisker appears way longer than the other. Would you guys say data A is skewed or not skewed?
Not skewed.
You are correct. Write that down. It's definitely not skewed. So now let's look at a different one, data B. Would you say that's skewed or not skewed?
Yeah.
Why is it considered skewed? Because that whisker is way longer than the other whisker. The two data sets contain an equal number of values. Okay, so they each have those 5 points, the lower and upper extremes, the interquartiles, it's got the upper and lower quartile, and it has a number in the box. It has the median in the middle. All right, the double box and whisker plot represents the values in these data sets. Let's just imagine that down here, these are talking about the number of calories in some kind of a food, okay? So compare the data sets using measures of center and variation. The first thing I want to do is focus on the data set A that we have up here. I want you to find the median of data set A. Is there anyone who thinks they might know what the median is of data set A? Jonathan, what do you think?
60.
Okay, we'll talk about that. That is correct. It is 60, okay? Before we do that, I want you to underline measures of center. Another word for measures of center, do this with your red pen, is the what, class?
Variation. Oh wait, no, median.
It is the median, okay? The median is another name for measure of center. So if I ever ask you to compare the medians, that means compare the measures of center. All right, the variation. Another name for variation is this word that I taught you today, IQR, which also means the range. Okay, so those are the two things we're going to be comparing. As Jonathan just told us just a minute ago, he says the median up here on data set A would be 60. Okay, so what he did is he went up here, he looked at the top, and he found what came right here in the middle. And that's the median, that is data set A. Now I want us to look at the IQR. In order to find the IQR, you are going to, once again, we're only focusing on data set A. You are going to take the upper quartile, which is this one right here. It's the top of the box. and subtract the lower quartile or the bottom of the box. So what numbers should I be subtracting, Michaela?
130 minus 20.
Nope, we're only focusing on data set A. Luke, can you help her?
80 and 30.
Okay, very good. You can see 80 is up here at the top. So we're going to take 80 and subtract. Do you see how I'm doing it, Michaela? The bottom number of the box, which is 30. All right, so Jocelyn, what would my IQR be? Jace, help her out. 50. 80 minus 30 equals 50, so that's my IQR. Let's now look at data set B. So when I'm focusing on data set B, we are only looking at the bottom box and whisker plot. Reagan, you may. All right, Ellie, can you help me? What would the median be of the data set B? 90 is correct. Okay, all she did was she looked at the middle of that box. That's where the median is. Good job. Who would like to help me with the IQR on data set B? Michaela, she wants to try again.
100 minus
You are correct. So what would the IQR be?
20.
It is 20. Good job, because 100 minus 80 is 20. Remember, once again, all you're doing is you are taking the upper part of the box and subtracting the lower part of the box, and that will give you your IQR. So now what it asks us to do is compare the measures of center and the variation. So we're comparing the two data sets. So if you would, just off to the right or underneath if you have some space, I want you to write this down. Data B has a greater measure of center. So that basically means data B, the median is 90, and then data A, the median is 60. So all we decided there is data B has a greater measure of center, or it has a greater median. Now it doesn't just ask us to only measure or compare the median, it also says to measure the what?
The variation.
The variation, okay, or the IQR. Would someone be willing to compare what we just discovered about the two data sets IQR? Jonathan, what do you think?
IQR data set B is smaller.
Okay, very good. All right, so he said data set B is smaller, or you could say data A has a greater variation. Either one. You could tell me which one is smaller, or you could tell me which one is bigger. All you're doing basically is comparing the two. Let's look at question B. It says, which data set is more likely to contain a value of 95? So basically what that's meaning is, if I look at my number scale up here, which box would 95 fall in? Okay, so we're going to put a 95 here, and if I were to just compare it up here on the number line, do you guys see that this is where the 95 would fall? Okay, so if I were to take my arrow and go up, would that 95 land in the box on data set A or data set B?
Data set B.
Data set B is correct. Okay, now it asks us to compare one more thing. Looking at problem B, it says, what about the number 70? If I was to look on my number line and I see the number 70 right there, which box would the 70 land in? Data set A. Look, it goes straight up and lands in that box. So you are most likely going to find a 70 in data set A. So basically all we're trying to do here is compare the data and look to see where would I find these different numbers. Where would they land? Let's look at another one. Question C. Which data set is more likely to contain a value that differs from the center by at least 30? Help me out with this word differs. What does the word differs mean? Different, okay? So it's different from the center by 30. What is the center on data A? 60. Here's the center right here, okay? If I go to the top of the box, how much is that top of the box different from the center?
20.
20, good job, because 60 to 80 is 20. So that's not the answer for that one. But what about if I say from here and I go to the bottom of the box? How much is that different?
30.
30. So that tells me data set A differs from the center by 30. Let's check to see if data set B also differs from the center by 30. Here's the center. looking at the top of the box, because we're just focusing on that 50% of the data, that box. How much different is the top of the box or the upper quartile from the median? 10. So that's definitely not differing by 30. Let's look at this part. From here to there, how much does that differ from the lower quartile?
10.
Only 10. So could the answer be data B?
No.
No, it cannot, because data B only differs by 10 and not by 30. Any questions about that? All right, we're going to do another example exactly like that. So if you would turn the page, let's look at this one. Tonight's homework, you have a worksheet, and it's going to look very similar to the problem that we're about to do. So I want you guys to take a minute and read this one on your own. Okay, so once again, we are comparing two different box and whisker plots. It looks like here we're talking about facility A and facility B, and there is a wait time. Where is somewhere that you might have a wait time at a facility? The doctor's office. That's exactly what I was thinking, okay? So which one of these doctor's offices did somebody have to wait the longest? A or B?
B.
B. How long was the longest they had to wait?
45 minutes.
45 minutes. Where had the shortest wait time? A or B?
A.
B.
Oh, wait.
Also B. What was the shortest time someone had to wait?
Oh, 5.
Only 5 minutes. Which one would you rather wait, 5 or 45?
5.
I'd way rather wait only 5 minutes so I can get in and out of the doctor fast, okay? So we're going to compare the sets using the measures of center. Remind me again, guys, what's the measure of center mean?
The measure of center is the median.
The median, good job. And the variation, which we're calling our IQR. So let's focus on these data sets. First off, let's look at A. I want to find the median of data set A. Halen, what's the median of data set A? 20. Very good. Now, let's talk about B, facility B. Jocelyn, what is the median of facility B? Remember, you're looking for the middle number in the box, or the dot that's in the middle of the box. Also 20, okay? So it looks like when we're comparing here in just a minute, they're going to have the same measure of center. Let's talk about the IQR. Autumn, how do I find the IQR again?
It's the smallest number, the biggest number in the box minus the smallest.
Good job. The biggest number in the box and subtract the smallest number in the box. So what are your numbers that we're going to be subtracting?
In facility A is 25 minus 15.
25 minus 15 is correct. So what's the IQR?
10.
Okay, so the range of the data in facility A is 10 minutes difference, okay? Let's talk about the IQR over here for data B. Madison, can you find that for me?
It is 35 minus 15.
35 minus 15. And what is that answer, Madison? All right, so now it's asked us to compare that. When I'm comparing it, let's compare first off the measures of center. What do you guys notice about the measures of center?
They're the same.
Very good, okay? So we're going to write here the measure of center is equal. All right, now let's go ahead and compare the variation or the IQR. Which one is bigger, guys?
Data set B.
Data. Facility B or data B, either one. We would say data A. Sorry, not data A. Data B has a greater variation. All right, now I want you guys to look at B and C. Talk with your partner and see if you guys can answer B and C. Okay, who would say for B, which data set is more likely to contain a value of 30? What did you guys get?
Data B.
She says data B, all right? If this is 30 and I go up, it would land in the box for facility B or data B. You are correct. Let's look at the next one. Which data set is more likely to contain a value that differs from the center by at least 15? Raise your hand if you said A. Raise your hand if you said B. Correct. Everybody got B because if you look at the top, this data set up here, whether you are going to the left or the right, it only differed by 10 from the center. So we know for sure it would not be that one. Okay, so there's something I want you to write in here, if you would. Please write in the 2 times, and then I want you to actually take your red pen and draw a cloud around that statement that I have in red on the board, because this is the most important new idea that I'm going to be sharing with you in our modeling real life problem. All right, so this is what it says. The double box and whisker plot represents the heights of roller coasters at 2 amusement parks. How many of you would say you enjoy roller coasters? Okay, where's a park that you like that has really good roller coasters? Ellie? Busch Gardens, okay? So we're going to pretend that this one right here is Busch Gardens for Park A, okay? What's another one that you would say has really good roller coasters? Abigail? Universal, all right? So we're going to call it Universal Studios. I'll just put US, okay? So we're going to pretend that's what we're comparing. These are not actually comparing those two. We're just pretending, okay? So first things first, we're trying to figure out, are the roller coasters significantly taller at one park than at the other park? According to what we just came up with, guys, which one of these 2 parks, Busch Gardens or Universal Studios, has the tallest roller coaster?
Busch Gardens.
Busch Gardens, how tall is it?
70 feet.
Okay, very good, all right. But it looks like overall 50% of the data, which one does it seem has taller roller coasters?
I would never read that.
Universal, okay. It's an amusement park. All right, so as we're looking at this, help me out with this first question you see there. Is the data skewed?
No. Yeah. In A. One is really long.
In A it is, good job, because it is a little bit longer. It has that really long whisker. So yes, the data is skewed. Now let's just figure out what we can see here. Let's talk about Park A, which we called Busch Gardens. What is the median of Park A, class?
50.
50, good job. Remember, all you're doing is you're just finding the middle number of the box, the dot in the middle of the box. Reagan, let's talk about the median at Universal Studios. What is the median, or the dot in the middle of the box of the Universal Studios one? 55, so that's the median over there. Now let's talk about the interquartile range. How do we find the interquartile range?
Use a triangle.
You look at the box. We're only focusing on the box. The top number of the box, the upper quartile, subtract the lower number of the box, the lower quartile. So guys, what numbers am I subtracting?
60 and, 55 and 45.
55 minus 45. Nasir, what's that answer? 10. Okay, so they have an IQR of 10. Basically what that's saying is those roller coasters are about 10 feet different in height. 50% of those roller coasters are. Okay? Now, let's go on. The IQR of Universal Studios. Who can help me with how to find that? Halen, go ahead.
Want to tell you the answer?
Yeah, how do I find the IQR?
Well, you
Okay, because we've got 60 minus 50, the answer is 10. So my question is, going back up there, it says, are the roller coasters significantly taller at one park than the other park?
No.
Now look, in order to be significant, there's a way we figure this out. The difference of the 2 medians has to be at least 2 times the IQR. Let's talk about the 2 medians. One of them was 55. The other one was 50. Guys, what's the difference in those medians? 5. Is that number 5 2 times, or is it double what we came up with for our IQR?
No.
No. In fact, it's not double, it's what?
Half.
It's cut in half, okay? So the answer is no. And I want you to write this down. We're explaining why. The difference of the medians, which we decided was only 5. Remember, we did 55 minus 50. Is not, I'm going to underline that twice so you understand, it is not 2 times the IQR. And the only way that it would be significantly taller is if it was 2 times what we came up with of the IQR. All right, for the next one, we're going to have the same idea once again. The double box and whisker plot represents the weights of cats at the animal shelter. As you can see, it looks like one has much larger cats than others. We are trying to figure out, are the weights significantly heavier at one shelter than the other? Looking at the picture, you would say yes, but we have to do the math to see. Remember, to be significant, what do we have to do, class? The difference of the two medians must be at least 2 times the IQR. So let's focus on shelter A. What is the median of shelter A, class? 7. Okay, that's the number in the center. Let's talk about the median of shelter B. What would it be? 8. So we know right now we're going to have the difference of those two medians. Guys, what's the difference of those two medians? 1. 8 minus 7 is 1. Okay, let's now talk about the IQR. Remember, you take the top of the box and subtract the bottom of the box. So we are going to have 9 minus 5, which equals? 4. Let's talk about the IQR for shelter B. How would I find that?
11 minus 7.
11 minus 7, which is?
4.
No, 4.
4. Okay, so remember, once again, we can see here the answer has to be no. What did we say that the difference of the medians was?
2 times. Oh, wait, sorry. 1.
It was only 1. Is 1 2 times the number 4?
No.
No, it's much smaller. So I want you to write this down. The difference of the medians, which was only, I'm going to put in parentheses, only 1, is not 2 times the IQR, which we found out was 4. Okay, so just remember that idea. If something is significant, it has to be at least 2 times the IQR. All right, tonight's homework is a worksheet, so you do not need to go on to Big Ideas to find it, but just bring it back with you tomorrow.